Hello, today I'm going to solve a problem on simulation of force convection heat transfer in a horizontal channel using ANSYS Fluent. So let us now at first open the ANSYS workbench. So now click on Add Fluid Flow. Now we have to at first we have to create a horizontal channel. So right click on geometry, then click on new design modeler geometry. So this will open. So here we have to click on XY plane, then click on sketch, then click on line, then draw the uh, required channel. Now let us give the dimension. Now let me change the dimension of H1 and H2. Let me put H1 equal to 0.15 meter. Click on enter and also change the value of V2 as 0.04 meter. So you can see this is the required horizontal channel. Now we have to extrude it. So click on extrude, click on XY plane, click on sketch one, then we have to apply. Now let me change the depth to 0.005 meter. Enter. So now let us click on generate. You can see the slab is now the channel is now generated. So now let us go back to workbench. Here we have to do the meshing. So right click on mesh, then we have to click on edit. So this page is now open. You can see now we have to right click on mesh, then we have to generate mesh. You can see the mesh is done. Now again we have to right click on mesh, then we have to click on insert, then we have to click on size method, then we have to select the geometry, then click on apply, then we have to change the method as sweep. So then I can click on generate. So you can see it is done. So the meshing is done. Now again we have to right click on mesh, then click on insert, then click on sizing, then select the geometry, apply. Then we have to change the element size. So let me change. Uh, Let me at first change this to 0.002 meter. Click on enter. Now click on generate. So this is done. You can see the meshing is done. Now let me do the meshing on the edge areas, so more refinement can be provided. So right click on mesh, then click on insert, click on sizing again, then uh, we have to at first now select the uh, edges. So let me select the edges first. This one is one, then this one, this one, this one, and this one. So now click on apply. You can see 8 edges are selected. Now we have to change the element size. So let me give it as 0.0005 meter. Enter. Now click on generate. it is done. Now you can see the mesh area, mesh portion. See, the edges are more refined. So now let us again go back to Workbench, then right click on mesh, then we have to click on update. So you can see the meshing is done. Let me edit it because I have to add the names of these uh, faces. So let me first select the face of this and name it as inlet, because this is the inlet, and also name this as outlet. And this as the top wall. Top wall. Click on OK, and this one is bottom wall. Click on OK, and this as the side walls. Click on OK. So you can see the names are created: inlet, outlet, top wall, bottom wall, side wall. Now we have to click on go back to Workbench and again update the mesh. You can see it is now updated. Now let me click on right click on setup and click on edit. It will take little bit time. Now let me click on double precision, then start. It will take a little bit time. So let me discuss the question, what the question asks us to do. The question asks us to set a wall temperature, then find out the temperature distribution, velocity, boundary layer development, and thermal boundary layer development for different inlet velocities. So we will be putting three different inlet velocities and see what would be the variation in the temperature distribution, velocity, boundary layer development, and thermal boundary layer development. So you can see now this is now done. You can see this is the inlet area, this is the outlet area. So the fluid is going through this surface and then coming out through this. So let me first click on model, then click on energy, then we have to click on energy equation, then OK, and also we have to click on viscous, then omega, and this is already selected, so we have to click on OK. Then we have to select the material, so we have to click on here, then we have to click on fluid, then you can see the air is selected, so you have to click on air. You can see we do not have to change anything here, so just click on change and grid. This will give us the fluid as air. Okay, now we have to do the boundary conditions, set the boundary conditions. So click here, then click on inlet. So I have to say, give the inlet velocity at first. So at first, let me give the inlet velocity as 0.1 meter per second. So click on enter, uh, click on apply. It's done. Now inlet is done. So now let me give the wall, bottom wall, the constant temperature. So let me click on bottom wall, then click on thermal, then then this thermal condition should be changed to temperature. I have changed to temperature, and also change the temperature to 400. 400, then click on apply and close. Now we do not have to change anything here. So then uh, we will click on methods here. Then we have to, since this scheme, it is by default it is selected as couple. Now we have to select it simple. Yeah, this is done. Then we have to click on monitor. Here we have to click on residual. Here we have to change the value of these two by giving two more zeros. So this is done. Now let me click OK. So this portion is done. Now let me do the initialization. So click on initialization. Then we have to click on initialize. Now see, the initialize is done. Hybrid initialization is done. Now let me click on run calculation. So let me give the iterations, number of iterations as 500 and click on calculate. So it will take a little bit time. So now I have given the inlet velocity as 0.1 meter per second. So for this inlet velocity, we will see the temperature distribution over the horizontal channel, and also the let me see the question, and also the velocity boundary layer development and thermal boundary layer development, and also we'll compare it. So it may take a little bit time. Okay, now calculation is now completed. So at first, let us see the temperature distribution. So for that, we have to click on graphics. Then we have to click on contours. Yeah, here, since we are seeing the temperature contour, so we have to change this to temperature. Then click all the options here as mentioned: bottom wall, inlet, outlet, side wall, top wall, and click save and display. So you can see, this is the inlet portion, this is the outlet portion. So the inlet velocity is 0.1 meter per second, and this is the temperature distribution for this velocity 0.1 meter per second. This is the temperature distribution. Now let me see the thermal boundary. Let me see the thermal boundary layer development. So let me click on XY. So let me click on plot, then click on XY plot. Then click on temperature. This is the temperature. So you have to click on bottom, inlet, outlet, side wall, top wall. Top wall is selected. No, top wall is not selected. Top wall. Then uh, save and plot. So you can see this is the this is the thermal boundary layer development for 0.1 meter per second in inlet velocity. So similarly, let us see the velocity boundary layer development. So for that, we have to cross section. We have to means the divide the channel into four cross section planes. So we have taken four cross sectional planes from there. So for that, we have to click on XY plot. Then we have to again create new surface. Then we have to click on plane. Here we have to select plane 0 name plane 0 and give this value as 0 and click on create. So you can see plane 0 is created. Similarly, we have to create one more plane, that is plane 1, and we have to give this value as 0.01 uh, 0.01. So click on create. So you can see plane 1 is also created. Similarly, you have to create one more plane, plane 2, and change the value to 0.05. So click on create. Similarly, we have to create one more plane, that is for lane number 3, and change the value to 9. So this planes means this plane provide us thermal boundary velocity boundary layer development in 4 different planes, that is 4 different cross-sectional planes of the channel. So plane 3 is created. Let me close this. Now let me select this plane 0, plane 1, plane 2, and plane 3. And also, since we are now changing the velocity, we are seeing the velocity boundary layer development, we have to change this. We have to create a velocity. Then we have to click here. Uh, we have to click here x-axis x. Here we have to change this to x velocity. Then this one is okay. Then we have to change this one by 1 and this one by 0. Now we have to place it. So you can see this is the velocity boundary layer development for inlet velocity 0.1 meter per second. Similarly, we will see all the thermal distribution, thermal boundary layer development, and velocity boundary layer development for one more uh, inlet velocity, that is 0.5 meter per second. So let me change the now inlet velocity. Click on inlet velocity, then click the velocity magnitude by 0.5 meter per second. Now click on apply. So this is now changed. Now after that, we do not have to change anything here. We just have to do the initialization process. Yeah. So click on initialization, then click on initialize. Yeah, okay. So it is showing. So hybrid initialization is done. Now click on run calculation. Now we have to click and calculate. It will take a little bit time. So since it will take, let me tell something. Since the inlet velocities are different now, at before we have taken the inlet velocity as zero point 0.1 meter per second. So the temperature distribution, the velocity boundary layer development, and the thermal boundary layer development, all of them will be different compared to this result, because this inlet velocity is changed to 0.5 meter per second. So let us see what changes does it occurs. Okay, now the calculation is completed. So similarly, now let us see the thermal distribution. So click on counter. Then we have to select the bottom, inlet, outlet, uh, sidewall, top wall. Okay, now click on save. So you can see the changes. Okay, see, you can see the changes. So this is the changes that occurs when we have changes the velocity. Now let me click on let me see the thermal boundary layer development. For that we have to click on XY plot, then select the we have to sorry, there was a mistake in thermal distribution because here I have selected the pressure. Let me select is temperature. Now let me select the bottom, inlet, outlet, and deselect it. Now you can see that the temperature distribution is different as compared to uh, the temperature distribution that we got when the inlet velocity was zero point 0.1 meter per second. So this is the difference of the temperature distribution in the uh, slab. See. So let me now again see the changes in thermal boundary layer development. So for that we have to click on XY plot. Then we have to change the to temperature. Then we have to select this bottom, inlet, outlet, then sidewall, then top wall, and click save. So you can see this is the changes that occurs in thermal boundary layer development when we change the inlet velocity to 0.5 meter per second. So similarly, let me see the velocity boundary layer development changes. So at first, then we have to click on XY plot. Then we have to change this to velocity, this one to x velocity, and change this value by 1 and this value by 0, and then we have to select the cross sectional planes, this one of this channel, this one and this one. So let me click on save. You can see this is the velocity boundary layer development for the inlet velocity 0.5 meter per second. So this is the changes and comparisons we have done. So thank you.